Okay, in this video lecture, we are going to discuss about voltage regulator ICs, integrated circuits which are designed particularly for regulating DC voltage. You can find different kind of voltage regulator integrated circuits on the market, but generally these devices are designed in two categories. So the first category of this voltage regulator ICs are what you call it fixed voltage regulator ICs. As you can see, these fixed voltage regulators, they when we say voltage regulator, it's a device which is used to generate regulated fixed DC from unregulated DC input. It generates regulated fixed DC output. So when we see voltage regulator ICs, integrated circuits, which are designed to convert unregulated DC input into regulated DC output, they are generally classified into two. Some of the ICs are fixed regulators, and another voltage regulator ICs, which are adjustable voltage regulator ICs. So generally it's classified into two: fixed regulator ICs, and the second one, what we call it, adjustable regulator ICs. So we'll discuss these two one by one. So let's start from the fixed regulator ICs, integrated circuits. So as the name indicates, these fixed regulator ICs designed to generate fixed regulated DC output. You cannot adjust the output voltage as per the requirement. So that's why these regulator ICs are called fixed regulator ICs. The output voltage, the regulated output voltage, DC voltage, is not adjustable here. Again, these fixed regulator ICs are generally classified into two. When you see series 78XX, so this fixed voltage regulator ICs voltage regulator ICs are integrated circuits. Again, broadly classified into two. The first one is positive fixed voltage regulators, which are commonly the 78XX series. Some fixed voltage regulators are negative fixed voltage regulators. The most common negative fixed voltage regulator series are 79XX series. So these fixed voltage regulators, very popular fixed voltage regulator, which generates fixed positive DC output, which is regulated. The most popular are 78XX series, and the most popular fixed negative voltage DC regulator ICs are 79XX series. So we'll discuss these 78XX and 79XX series voltage regulators one by one. So let's start from the 78XX series. Okay, so there are different manufacturers, but the most popular manufacturer LM78 series, LM. So as you can see here on the IC, on this integrated circuit, you can clearly read this is L7815, right? 7815. You can see here this IC is LM7805. You can see here. This IC LM7809. This one L7815. So 78 is fixed. Why we call this ICs 78? Because on the IC number you see 78 is fixed. So 78 indicates these ICs are positive voltage regulators. They are positive positive fixed voltage regulators. Which means they convert unregulated DC, the input, into positive regulated output, which is a fixed value. So you see here the last two numbers here denoted by XX can be 0, 5, two numbers, right? One X, another X. It can, in this case, the IC is, as you can see here, it is what? 7805. You can clearly here read on the IC 7805. 78 indicates this integrated circuit is first, it is fixed. Fixed means the output DC voltage is fixed, you cannot adjust it. Second, 78 indicates it is positive DC output. And the last two numbers, 05 indicates this IC 7805 generates positive 5 volt, fixed positive 5 DC regulated output. 7805. If this XX numbers 09, so the IC in the first case, when the last two XX, when it becomes 05, the IC number becomes 7805. So from this IC number, you can clearly understand 78 indicates it is fixed positive voltage regulator. The last two numbers indicate the amount of DC regulated output voltage. In this case, how much? 5, positive 5 volts DC. How about 7809 IC? 7809 IC. So here again you can see 78 tells us this IC is fixed positive voltage regulator. How much voltage? 9 volts. So this one positive 5 volt output. 7809 IC will generate positive 9 volts because this is 09. What will happen if this is the last two numbers 12? So what will be the IC number? 7812. Okay, so for example here, when you see this IC, when you read the IC number here, it is 7806. So immediately we can understand it's positive, fixed positive regulator. The output voltage will be 6 volts. How about here? 7812. How much regulated output? Positive 12. Here 7, 8, 18. So you can see the amount of regulated DC output is 18 volts. How about this one? 7, 8, 24. This IC will give us a DC voltage of 24 positive. Okay. So as we have discussed, voltage regulator ICs, they are designed to regulate DC voltage, convert unregulated DC input into regulated DC output voltage. And this voltage regulator ICs can be two categories: fixed voltage regulator ICs and adjustable ones. This ICs, what we have discussed now, the fixed voltage regulator ICs. Again, the most popular are two types: 78XX series, which are the positive one; 79XX series, which are the negative voltage regulators. So now we are discussing 78 series. These ICs, the most popular positive voltage regulator ICs, 7XX series, they are all 3-pin ICs. They are all 3-pin. As you can see here, pin number 1, pin number 2, and pin number 3. They are all 3-pin devices. So when you see the pin diagram, you have to refer the data sheet of these voltage regulators in order to identify which pin is input, which pin is output, and which one is ground. But in LM78 series, when you put your IC in this front direction, this is the output pin. Output. This one is input pin. To the right, you have input pin. To the left, we have output pin. The middle one is the ground pin, the common. Okay. But when you turn it, the IC upside down, this manner, this is the back side. No, the front side is from here. But if you put it in the back side, now this is input pin, this is output pin, and the middle one is the ground. So here, so this pin is output. This pin on the right, input, which means we apply unregulated DC input on pin number 1. Here, the output pin, you get regulated output. So if you take 7805 IC, the input voltage, you can vary it from 7.5 up to 18 volts. Again, you have to refer the data sheet. When you use any regulator, please refer the data sheet. What will be the input voltage range for this particular ICs? So LM7805 ICs, input voltage can range from minimum 7.5 volt up to 18 volt. What will be the output voltage here? It's fixed voltage, fixed regulator, and it is 7.8. 7.8 indicates positive. The next number indicates what? 5 volt. 7805 means you will have regulated positive 5 volt output. The input, you can give it from 7.5 up to 18 volt. It will fluctuate, right? It will fluctuate. Why it fluctuates depends on 2 reasons. First one, fluctuation on the line voltage, the AC input voltage fluctuates. Second, when you change loads, it will cause this DC voltage fluctuation. So these unregulated inputs, now we have regulated fixed positive 5-volt output from these 7805 integrated circuits. So let's see. Let's see here. So pin number 1, in this case, is our input, unregulated input. Pin number 2 is, as you can see here, is the ground. It is 3-pin device, right? We have discussed. Pin 3, regulated output. Which integrated circuits we are using? As you can see here, it is 7805. I choose 7805. So 78 indicates the output DC voltage is positive. 05 indicates the regulated output is DC positive 5 volts. Now here the input voltage unregulated can range from 7.5 up to 18 volt, whatever input voltage DC. In this range, this IC will give you constant 5 volts. So let's check how much DC input. Here, let's apply, start from 7.5 volt input. So let's see the output. The output you can read by this voltmeter here. Okay, now it's done. So how much? Positive 5 volts. The output. I connect output to my voltmeter here. So you can fluctuate, apply 10 volts on input side. The output still remains positive 5 volts because this is fixed voltage regulator. You cannot adjust it. Okay, we cannot adjust it. This, if you are using this IC in your circuit, it will always generate positive 5 volts fixed. Now, if you replace it with IC 78 is positive. I need positive 9 volt. 7809 IC. Okay, now I bring, as you can see here, it is IC number 7809. So unregulated input here, regulated fixed output here, and ground connected to the ground. Now this is 7809. So input voltage can range from 12 volts. Now input voltage is 12. How much voltage you expect in the output? Because this is 7809. 09 indicates this is positive fixed voltage regulator, constant 9 volt output, positive. So let's check. So as you can see here, our DC voltmeter reads positive 9 volt. So you can change your input, can fluctuate, but we have a very regulated positive 9 volt output. Okay, let's bring 7, 8, 12. So this is 7812 IC, 3 pins. Pin 1 input, pin 2 ground, the middle one, and pin 3 to the left is the pin 3, will be the output. Now, this is 7812 IC. So if you are using 7812 IC, these integrated circuits generate positive 12 volt, fixed positive 12 volt, regulated 1. So let's say we apply 15 volt as input. So you see here positive 12. If you give it 20 volt DC, input 20 volt DC, the output remains positive 12. So it generates, why it's positive 12? 7-8 indicates positive, 12 indicates the amount of voltage this voltage regulator IC generates. Now when you see this experiment, this is the voltmeter. So in this case, there is no load connected. This IC, as you can see here, is 3-pin IC. In this case, it is 7812 IC is used. 7812, 3 pins. Input unregulated DC here, output regulated. So this meter will read output, which is regulated 1. This is our load. This experiment, as you can see here, this is LEDs, one load in series with another motor connected to the output. So this regulated output goes to the LED plus the motor. Now with no load, the input voltage 17.79 volt with no load condition. This IC gives us 12.06. In this case, what we call it load test. The input voltage is not changed. The AC voltage is fixed. But when you change load, you can see there is a change in voltage. Now, when this input, the output is fixed, as you can see here, 12.06, because this integrated circuit here is 7812. Okay. Now look. Now when the load connected, which load? The motor. The voltage, this unregulated voltage changes. Why it changes? Because it is unregulated. When there is a load, the DC voltage fluctuates. Let me repeat. Without load, how much you read? 17.75 volts, right? This is without load. Check now their unregulated input and regulated output. Whenever you connect the load, this unregulated will change, right? But this IC makes it regulated, always 12 volt. Whatever load you connect, you change your load. That's the purpose of voltage regulator. So you can see here, when the motor is connected, this voltage fluctuates. How about the output? Still remains 12.06 because of this 7808. Now, when this another load here, as you can see, the light emitting diodes, okay, when they are again connected, look now, two loads. This input fluctuates, but still the output voltage remains 12, fixed 12 positive voltage. Whatever load you change, because as we have discussed, why DC voltage fluctuates. One reason is load. Another reason is AC supply, right? When you change load, your DC fluctuates. When you AC input voltage change, your DC fluctuates. We don't need this fluctuation. This fluctuation makes our system works improperly. The system will be damaged. If it's sensitive devices like digital ICs, it will be damaged, or it may not be damaged, but it does not work properly. So these systems need regulated DC. That's why we need this voltage regulator ICs here. Okay. So this is 7-8. As you can see, it's 3-pin device. Two capacitors, C1 and C2. They're optional, but it's very good to use. C1 microfarad, 1 microfarad capacitor. This is 0.1 micro. You can use different capacitors, but C1 is used for smoothing ripples. If there is any ripple from this unregulated side, we have discussed what ripple means. This capacitor will smooth. So we have smooth DC input. So this IC 3 inputs, right? So 3 pins. Pin number 1 input, pin number 2 ground, pin number 3 output. So another capacitor C1, which is used on the load side for load balance purpose. Okay, so when you see 7-8 XX series, it has 3 pins. Pin number 1 input, pin number 3 output, and pin number 2 will be ground. It's very simple construction. So here we apply voltage, but which is unregulated. As you have seen, it will fluctuate, depends on your load and the AC input, but this IC will generate regulated output, but it is fixed amount. Positive because it is what? 7-8. How much voltage? XX. The next two numbers indicates how much voltage this IC generates. Now these fixed voltage regulators, also we have negative voltage regulators. In many applications, we need both positive and negative DC. For example, when we discuss op-amp, if you remember in chapter 1, when we discuss op-amp needs both positive 50 volt and negative 50 volt, right? DC, both polarities, op-amp. Many systems also, we need positive and negative voltage, like this op-amp. So we need regulator ICs, fixed voltage regulators, which generate negative voltage, negative DC. These ICs start with 7-9. As you can see here, these IC numbers start with 7-9 series. They are called 7-9. We have here 7-8 series, they are positive voltage regulators. 7-9 series, they are negative voltage regulators. So if you have IC start with 7-9 and 0-5, what does it mean? This fixed voltage regulator which generates negative voltage. How much? It will be 5 volts, because this number indicates the amount of voltage. In this case, it will be negative voltage. Okay. 7-9-15. If you are using 7-9-15, what will be the output voltage? Minus 15 volts. Let's check this using our So let's bring 79 series 15. Okay. Now this IC 79, right? So in this case, it is different. The pin diagram for 78 series, pin number 1 will be pin number 1 input, pin number 3 output, pin number 2 ground. But here, pin number 2 is input, the middle one. So for negative voltage regulator 79 series. So I give here the unregulated input, let's say minus 20. Pin number 1 in this case will ground. Pin number 3 is the regulated output. Now how much output voltage we expect? Because when you see 79, it's negative. The next number is 15, so we expect negative 15 regulated DC voltage. So let's check. Yes, you can see here the input is 20 minus 20, but always this IC will give us a negative 15 volt because it is 7915 series. If you bring 7906 integrated circuits, pin number 1 is ground, pin number 2 is input, pin number 3 is output. So let's apply here minus 10 volts. So what will be the output? Because this is 7906, here you see we have 06, so the output always will be negative 6 regulated output. So far we have discussed this positive and negative fixed voltage regulator ICs. The most common one, LM78XX and LM79XX series. Next, we have ICs which are adjustable ones. So in the fixed one, whenever you need 9 volt DC, you have to bring 7809. If you want 12 volt positive, you have to change the IC, bring 7812 IC because they are fixed outputs. But there are adjustable regulators. You can adjust the output voltage. As you can see here, the most common and popular adjustable regulator is LM317. LM317. Here, it is also 3-pin device, but the output voltage, here you can apply unregulated input voltage, DC. It generates output regulated, but it is adjustable. You can adjust the minimum 1.25 volt DC. You can increase it up to 37 maximum volt. It is adjustable. So here we have a potentiometer which is connected to the adjust pin, 3 pins here, input, output, and the adjust pin. So by adjusting this potentiometer, you can generate regulated DC output voltage from 1.5 up to 37 volts. So to summarize what we have discussed, we have seen voltage regulator ICs. Some regulators are fixed, like 78 and 79 series. We generate fixed positive and negative voltage. There are regulator IC like LM317, very popular, adjustable voltage regulator, which depends on R2 here. You can see the formula. The output voltage depends on what? R2. R1 is fixed. You can use fixed resistor here. So if you change, sorry, R1 is fixed. If you change R2, you can adjust the output for using this formula. So this LM317 also 3-pin device. Pin number 1 is input. Pin number 2 is adjust. And pin number 3 is regulated output. Okay, this will be output voltage. So LM317, this IC is designed to accept unregulated inputs up to 37, and it can generate a current up to 1.5 ampere. So whenever you use these voltage regulator ICs, it's better to refer the data sheets. What is the input voltage range these ICs will take? What will be the current these ICs can generate, maximum current? All these specifications of these ICs you have to refer before using these voltage regulator ICs. Okay.